Okay, we are starting our next talk. Please meet Edwin Derks. He's a principal software architect with Ordina. Hello, Edwin. Can you hear us?
Привет всем.
Привет.
I can hear you.
Where are you right now?
I am in the office in the Netherlands.
Oh, I see. So it's still morning on your side.
Yes.
Okay, I will not take much of your time. Please go on with your talk.
Okay, thanks. So, hello everybody. Thanks all for coming out to this session. Today I will tell you everything how you can optimize your applications with Jakarta EE and MicroProfile. So like 15 years ago, I myself started out as a Java developer, a professional developer. I was building business applications with enterprise Java. And as a developer, I built features and I was happily testing them and they worked functionally. But when I put my app in test and production, I sometimes found out that my app crashed, ran out of memory, was too big, was unstable, produced errors. And I didn't intend for any of that, but it was still happening. So as a developer, I learned and I grew more proficient over the years that I also needed to tune my app to run smoothly next to building the features that I needed to build for the business software. So in regards to optimizing your application, I will tell you everything about my experience, how that went over the years, and hope to inspire you that you also can build your enterprise applications as efficient as possible. Yeah, so like you just said, I was working for Ordina, but that's not true. As of this month, I am now a principal consultant for Rockstars IT in the Netherlands. I'm still working in the Java domain. That's still my specialization, but I will be consulting our customers how to move to the cloud, for example, and then how to use Java there. Next to consultancy, I am also active in the community. I'm still a writer. I write blogs and articles, and I speak at conferences like this, which I very much like to do, sharing my knowledge and get inspired by other people. And yeah, I also contribute to Jakarta EE and MicroProfile myself regularly because it's still, yeah, it's my thing. So I like to talk a lot about that. If you want to reach out to me, please find me on Twitter. You can also find my own website. So I'm mostly active there. But without further ado, let's dive into the talk. It's not really a beginner's talk, but I want to try to keep it high level and not go into too much detail so that everybody can follow along. But a little bit of experience with Jakarta EE or Spring Enterprise Java is recommended. If you don't have that, please follow along and try to apply the concepts that I will be speaking about today yourself afterwards. So because this is a conceptual talk, I won't show too many code examples, but I really would advise you to look into, for example, YouTube, where you can find other in-depth sessions, how to use the programming model of Jakarta EE and MicroProfile with the concepts that you have learned here today. So to start off, let's start with a little bit of background, because I'm talking about optimizing Jakarta EE applications. What are we actually optimizing and how did we get here? So over the years, Java EE and Jakarta EE nowadays have been evolving along with their counterpart, Spring and Spring Boot. So why is that? So 20 years ago, we didn't have clouds. We didn't have the scalable infrastructure. We didn't virtualize everything. We had these computers stored in the basement at companies, and that ran your application. But as virtualized hardware came up, the clouds came up, this opened new possibilities of building and deploying and running our applications. So the programming models and the implementations of these enterprise Java frameworks, they changed and changed according to the new possibilities, of course, that the hardware provided. So if you look at some maybe 5, 6, even 10 years ago, the Jakarta EE and MicroProfile, Jakarta EE and Spring really started to adopt cloud deployments. And from the Spring environment, Spring Boot was born. And from Jakarta EE environment, MicroProfile was born. So these are the frameworks related to their original counterparts to make really cloud-native development possible with everything that has been established over the years. Like I said, over the years, Jakarta EE is kind of old now, like 25 years, and Spring also. So there are a lot of perceptions from developers that I hear nowadays. They say Jakarta EE is old. That's correct, but is it necessarily a problem? And also here, Jakarta EE is slow. Well, Jakarta EE essentially is a set of documentation interfaces. So how can that be slow? Why are you saying that it's slow? And also the big one, Jakarta EE consumes a lot of resources. We have this big application servers consuming gigabytes of RAM, running for years, and they cannot be patched. Why is that? And also, Jakarta EE cannot be used for building microservices. Well, there is some truth to that, and I will elaborate in a moment. But as we look at these perceptions, are they all true? And not necessarily, and I will elaborate. If you look at the programming model that we have nowadays, over the years, it has grown into a very feature-rich programming model. And with the developers' inputs, it has grown so that developers still can work with it and should love it. So everything you need nowadays for building business software with Jakarta EE, MicroProfile, is in there. You can do WebSockets, you can do server-side events, you can do servlets, you can everything, databases, of course. Everything that you need essentially to build enterprise applications is there inside and matured to a level that we can use still today. So because it's old, doesn't necessarily mean it's bad. And Jakarta EE has optimized runtimes. Remember the monolithic application service that had this gigabytes of RAM? That can still be done, but it's not necessarily true anymore. The way Jakarta EE is being applied nowadays in modern runtimes, modern application servers, as I will talk about later in detail, there is where the real innovation is and was. So Jakarta EE for developers has been maturing as a programming model, but underneath running it, like I said, with Spring Boot and MicroProfile, adopting the hardware and deployment models that we use today has been done mostly under the hood. And that's where you can really profit as a developer. And also, yeah, Jakarta EE cannot be used for microservices. That's kind of true because Jakarta EE essentially doesn't contain the necessary specifications and program model for making it work in a cloud, like health checks and metrics and all the stuff that a cloud needs to see if your application is healthy and running. MicroProfile provides that. And because MicroProfile has the same ideology as Jakarta EE has, they perfectly fit together as a whole, and that makes Jakarta EE workable in modern cloud-native environments. So, if you look at where we can optimize Jakarta EE applications to make it all possible, running in the cloud as efficiently as possible, we have 3 areas that we can cover. The first one is building your application, not only as a developer using the interfaces to build your features, but there is more to that. You can also choose how to build your app, how to ship it, how to package it. There's a lot of interesting benefits to gain if you really think about what you're doing there as a developer. And because you can create experience for yourself The second one, run the applications, because Jakarta EE, the applications from the runtime, you have a choice on what. If you have, for example, server, you can change it with another one because you like it more for some reason. But you necessarily don't your app because the runtime is still compatible, and that makes Jakarta EE really powerful. And also how you can deploy it. Your app, you can run it, but it needs to go into the cloud. That does all the stuff a cloud does with your app. It needs maybe a container, it needs a runtime, it needs to deploy it. You also have choices there. So if you look at these three areas that we will cover, you can mix and match what suits you best. I will explain later on how to, for your project and your preference, optimally run your application. So first, let's see how we can build our app and what options that we have. If you look at the Jakarta EE ecosystem nowadays, we are working on Jakarta EE10. It will be released, I hope, in the second quarter of this year. But the current state is that we have Jakarta EE 9.1 as the latest version of the framework. Now, Jakarta EE 9 is an evolution of Jakarta EE 8, a technical improvement. A lot of technical stuff has been done there because Jakarta EE 8 was the version that was transferred from Oracle to the Eclipse Foundation when Jakarta EE became an open source project. So from Jakarta EE 10 on, we really expect the innovation to kick off and grow even better with the community, because we have a lot of community input nowadays to shape the framework as we as developers would like it to. Now, for the microprofile side of the fence, microprofile 5.0 is the current version. It is aligned with Jakarta EE 9, so we have the same technical base now, and we are gearing up for microprofile 6 this year and put all kinds of innovation there that we can realize. So microprofile is also evolving with Jakarta EE as we speak. But that doesn't necessarily mean that you have to pick one of these versions. You can have a runtime that uses Jakarta EE 9, for example, and microprofile EE 5, but also Jakarta EE 8 and microprofile 5, for example, 4.1. There's also a mix and match there, but that is sometimes a little bit confusing for new developers, I know. So, like I said, new developers, younger developers that start off with Java and Enterprise Java, there's one thing that I want to elaborate on, and that is how you run these applications as a software stack. So you can use Java to build your application and use a JRE to run your app. You can build GUI applications, you can build all these kind of low-level applications. But Enterprise Java is different, because the code that you build with Java SE and use the interface from Jakarta EE, for example, you don't run it directly. You put this code into a package, a jar, a var, or an ER that I will talk about later, but you cannot run that package. It's just a package of that code that doesn't do anything. You have to make it run with a runtime. And that's where the JRE comes in. You use your Java JRE to run a runtime that can run your package. So you can run, for example, your runtime, but if you don't supply it to the package, you have an application server that runs but doesn't do anything. So if you supply it then with your application, it starts running your application and your application is then working. And the most beautiful thing of all is because your code is compatible with Jakarta EE and MicroProfile, any application server that is also compatible can run your app. So you have, like I said earlier, the option to choose which runtime suits your project best. However, in order to build your app, you need access to Jakarta EE and comparing it to Spring, also Spring, but it is kind of the same if you use Maven. Maven is still the de facto build tool for Jakarta EE, at least. I see a lot of Gradle adoption with Spring. I see some Gradle adoption with Jakarta EE, but let's focus on Maven as a build tool for your applications. If you want to start off with Jakarta EE and MicroProfile using Maven, it's very simple. You make a new project, you put only these two dependencies in, and you have access to all of the features that Jakarta EE and MicroProfile provide. You don't have to pick or choose or whatever, use an interface to see which component you need for REST services or for servlets or for databases. It's all in there. It's immediately available to you, everything, because you have just these dependencies. And that's the comparison I want to make with a component-based framework like Spring. When you want to use databases in some sort of way, you have to find out which components of Spring you need for this feature. If you then want to expose it via a REST interface, you have to find the components for Spring that you need for making these REST interfaces. So your Spring application is more maintenance heavy than a Jakarta EE application. It's not necessarily a bad thing, but in my experience, I loved the way I could just start off with Jakarta EE and MicroProfile this way. And I had a lot of maintenance hell in my projects I did with Spring, because not always all these dependencies, all these components of Spring and the community were aligned. Sometimes there were conflicting dependencies, sometimes there were missing dependencies. My preference goes to Jakarta. And I will tell you later more in detail why. There's more to it, but that's the difference between a component-based framework and a specification-based framework, Spring and Jakarta. I have been talking about packages, packaging your application into some sort of archive that can be run by a runtime. So the options you have here are on the left side for Jakarta EE and on the right side for mostly Spring. You can use them for Jakarta EE as well, but the vision behind Jakarta EE is thin wars. And thin wars mean essentially only package your code. Everything to run it is in the application server. So the more dependencies you put into your thin var that are not necessarily your code, but dependencies to run it like a database driver or some sort of front-end driver library, then your thin var becomes a fat var. And it becomes less portable, it becomes larger in size, it becomes slightly harder to maintain. So the fatter your application becomes, the less portable and shippable it becomes. Now for Spring, they thrive on this. Using Tomcat to run a Spring application as a fat var is the idea behind Spring. But again, not necessarily a bad thing. Upsides, downsides. I'm just trying to elaborate these upsides and downsides to you so that you can choose for your own project what fits you best. So then you have to Uber and fetchjar. This means you put everything that is your code and everything for the runtime into the same package. So there's no split between the runtime and the code anymore. Spring Boot thrives on this. It's an idea behind Spring Boot. Put everything in a jar, run it in the cloud, and just go with it. Works perfectly. But again, as I will tell you later about, there are some very interesting downsides to it that are not always directly visible for developers. I really want to stress out later what this is, because it is important. And then there's a new kid on the block. It's a skimmed jar. And that's a kind of interesting topic I will elaborate later on. But it's essentially a thin var with a runtime that doesn't run the application. Very interesting. I will come back to that later. So these are the kind of the options you have with the enterprise archive also, but I'm leaving that out. It's just a package of what you see here. So, talking about security, I hope you as a developer are also, especially nowadays, concerned with how secure your application is. And if I look back in the past year, for example, a lot of stuff has happened in the community. CVEs, like last week, there was a Spring vulnerability. A few months ago, there was a Log4j vulnerability. And this is all possible in your app as a vulnerability if you have that vulnerability packaged inside or not. So security is a very important topic to adhere when you are building your applications. Now, the good thing is, if you write secure code with Jakarta EE, you put it in a thin var, the var essentially contains your code, and if that's secure, then it's as secure as it can get. It's the best option you have. And the skim jar is kind of the same, but you have the runner inside, and it's less secure-ish, but not necessarily a problem. It gets worse when you have this fat or uber jar that you compile by putting all the dependencies together. These dependencies can come from, example, Maven Central, and or something in between that shouldn't be there, or somewhere else that you don't or should trust. But the point I want to make is, if you have a Spring or a FedWar application, you write your code and then you say build, and then you start downloading stuff from everywhere, and that in the end is your application. But it's not necessarily the thing you should have or want to have, because something can happen in between that slips in that you don't want to have there. So it is an example that you see here from a Twitter discussion. One kind of feature you want for making a Spring application working results in 33 jars and a lot of class files, and apparently also some vulnerabilities with a default Spring application. So you can expect not to have vulnerabilities in your application when you build it, right? But unbeknownst to you, they are there. So it's not that this cannot happen with Jakarta EE. I will also talk about it later, but this is a thing you have to really understand when you are building Spring or FedWar or UberJar applications, that if you compile your app, that this thing can happen. So thin vars are a way to prevent this, but upsides, downsides. So when you have chosen how to build your app that you think is best for you, then you can start running it. And like I said, you have several options of running your app like you want it, as efficient as possible. And let's see how that works out. So to run a Jakarta EE application, we have the traditional application server. So a good big monolithic friend that has some misperceptions or misconceptions, but it's still my friend, and I will explain why. Then we have the Uber jar, the hollow jar, and the skipped jar to run your application. And all this relates to the packages I just have described, and I will let you see how that relates. But I want to start off with the application server. You can download any open source, maybe, or proprietary application server that is compatible with Jakarta EE or MicroProfile, or both, ideally. You can use this application server to run your app because it's compatible, because you have a version of Java that's compatible with all of this. So this makes an application server running, so you can access the endpoints, it starts doing database stuff like that, so your app is running. But what do we essentially have here? Like I said, you download your application server, mostly a zip file often. You unpack it, and then it has some file that you can use to start with Java, and then it starts on the application server. So what you see is what you get. This thing is as secure and stable as it can get. This is what you have. Remember what I talked about compiling your app? The application server is not compiled anymore because you have build scripts. This is what you have. So the app that you place on it is what will be run, and this is your infrastructure from now on. It won't change anymore unless you update the application server, of course. The nice thing of this is that your application server is being thoroughly tested by a vendor. The vendors, for example, Red Hat, IBM, Oracle, all these parties, they build an application server compatible with Jakarta EE and MicroProfile, and they want to have the best application server. So there's the competition and innovation there to make the best runtime for you possible. And you can choose which one suits you best. So all this stuff, making sure it's secure and making sure it's fast and stable, that is done by the vendor for you. And the vendor knows their product best. And because everything is now open source with Jakarta EE, you can also tell the vendor what you like or dislike, or suggest new features, new bug fixes. You can participate there also to make the product that you use even better. Now, might there be some problem with the application server and you need to patch it? Often changing a file or a library will patch your application server or download a new version, of course. But again, this is what you have and won't change anymore because this is what you run with. An application server is most suitable for thin FATWARs. Like I said, ideally for thin wars where everything to run the application is in the application server itself. I have been using application server Payara myself for the past years. And I was really, and I'm still really fond of it. So I will use that in the coming examples, but it's not necessarily Payara that you need to use. It's just they provide means for the examples I want to explain. But Payara is not the only application server vendor. If you go to this link, Jakarta EE/compatibility, you will see which application servers are compatible with which version of Jakarta EE and MicroProfile. So if you want to understand which application servers are out there, 20 years ago, I didn't have such a page, so I just had to learn the other way. But now we have one source of truth that shows the application servers that you can try out and see what suits you best. So next to the application server, we have the hollow jar concept, also from Payara, and that's called Payara Micro. This application server can still run your MicroProfile and Jakarta EE based application, but it's still disconnected from each other. You need to tell Java itself to run the jar that contains Payara Micro, and then provide as a parameter the web application that you want to run as a single command line. So what is the difference with the application server then? Well, Payara Micro is much smaller in size than the actual application server that I talked about earlier, even hundreds of megabytes smaller. Why is that? A lot of management and operational tooling has been stripped from Payara application server into Payara Micro, because in the cloud environment, it's unlikely that you are going to log into your application server to see what's happening there and try to stabilize it with the console and stuff like that. That's not how it works. So Payara Micro with hollow jar concept is more tuned to running in the cloud, where if your application is not running healthy, you shut it down and try to start up a new instance and see if that improves things. We are not going to stabilize the application there. It's a whole different paradigm of running your app. And Payara, for example, is adopting that ideology. So what you have now an application server as a single artifact that you don't have to extract in lots of files on your file system. It's just one application that you can run with Java. And like I said, it contains built-in operational management tools. But it's still enough app server compatible with Jakarta EE and MicroProfile to run thin and fat wars, just like a full-fledged application server can do that. It's just a different environment. Then we have the Uber jar. Also, applicable in the MicroProfile and Jakarta EE ecosystem, even though it completely contradicts the notion of don't put your application runtime into your together with your code. But still, why can you do it and why should you? Well, again, you have a jar with your code, but now Payara is put inside it along with your code. So instead of having it disconnected with the whole jar concept, it's now put together as an Uber jar. So you now need only Java to run this single jar, and then your application should run. But what is then the difference with the other options? Well, yeah, of course, it's bigger in size because you need to ship all the whole application with your code all the time. So if your app is only a few kilobytes in size, you now have to ship all the megabytes of the application server also. I will show that later. But the important thing to note here is, like I said, with Spring Boot and Uber jars, you compile a Spring Boot jar with downloading stuff from maybe Central or other repositories, and that results in the jar. But in the Payara case, you can extract an Uber jar from the application server you already have. And going back to the earlier concept, what you have is what you see is what you have. So you can safely extract an Uber jar from that if it's how you want to run your app, because nothing is in between anymore. You don't have to download stuff from the internet, and nothing can wrong in that process. It's perfectly safe to extract an Uber jar from an existing application server, and that's the real difference. Now, last but not least, the new kid on the block is a skimmed jar. Also supports or is compatible with MicroProfile Jakarta EE, as we are expecting. And again, we have a jar with our own compiled enterprise code. But like I said earlier, for example, Quarkus is a product that makes this possible. A runner is put inside. And still, this runner doesn't run the app because it has no dependencies and no application server runtime. But it is there, only separated from your application jar. And there's the thing. You can still run this with Java, like you do with the other options. You run the runner or the jar, so the runner runs and then looks at where the libs are to run the runtime. But this is more a component-based approach like we do with Spring Boot and Spring. So Jakarta EE and Spring ideology are kind of coming together here. With Quarkus, for example, you define what you want to use in your Quarkus app. And all these components are compatible with Jakarta EE or MicroProfile because it's still from Red Hat and they want to leverage the best breed of libraries from the community into Quarkus. And because we are so familiar with MicroProfile and Jakarta EE, why not provide the programming model of Jakarta EE and MicroProfile to work with Quarkus? They could possibly invent a completely new programming model, but they didn't. Luckily, they used a programming model that we already know and have and love, and also provide the Spring programming model for Quarkus. And this is the biggest point I want to make. The programming model that we know, Spring, you can use Spring for building Quarkus applications, you can use MicroProfile Jakarta EE. But underneath how these programming models are applied nowadays, that's where the difference is. That's where the innovation is. So if you say Jakarta EE and Spring are old, I'm not going to do it. I want to do something modern and fancy. Yeah, you can still do Quarkus modern and fancy with the programming models that are 35 years old. So that's pretty neat, in my opinion. So, when we have chosen the runtime of our choice, let's choose which version of Java that we are going to use for running that runtime with our app. Also choices there. So You can, of course, use the default Oracle Hotspot JVM that we also know from the OpenJDK, the open source Java project. But there is also a JVM available that's called Eclipse OpenJ9, donated from Red Hat, IBM. My apologies. It's because a JVM essentially is also a specification on how to run Java, and Hotspot is an implementation of that. Historically seen, OpenJ9 is also an implementation of Java. So you can build an app that is compatible with Jakarta EE and MicroProfile and run use a certain version of Java. But even this version of Java, you have options of which flavor, which JVM to use. So also choices there. And as you can see in this screenshot, when I was at a conference, they showed how the Spring Boot pet store run with Hotspot and OpenJ9. You see that there the memory differs quite a bit. Hotspot uses 455 megabytes and OpenJ9 only uses 159. The same app, just running it on two different JVMs. So what do you get out of that? Well, you can start experimenting and see what happens when you use a different JVM for your application without changing your application, because you don't have to, because it's all compatible according to the specification. So I did a test once on my own laptop, and I started a Payara Micro with Hotspot and OpenJ9, and then I put an app on it. And you see that the startup time of the application really differs based on Hotspot or OpenJ9. Doing the same on a new laptop, difference nowadays, with another version of Payara, you see that these numbers are different. So depending on where your app runs, what your app essentially is, in which environment, all these kinds of stuff, all these kinds of parameters can vary on how your application will behave when you run it. So just running your application, seeing, oh, it runs, it doesn't provide any errors, it should be good. It should be good, but it doesn't necessarily have to be. You have options to fine-tune it and make it better by seeing how it behaves with different implementations of, for example, the JVM. Especially if you put a stick in it and see what actually happens inside that application, you can see where it really gets interesting. On the left, I have run the Spring Pet Store with Hotspot JVM, and on the right with OpenJ9 and put Visual VM on it. You can see that on the left, Hotspot claims a lot of memory, like 1.2 gigabytes, but the CPU is like, okay, I'm running fine. I'm fine. Nothing to see here. Just give me memory and I'm fine. But the OpenJ9 JVM says, okay, I'm only claiming like 125 megabytes of RAM, way less than the Hotspot, but the CPU is working working something off to really make sure that the memory footprint stays down like that. So when you really look into your application, then you can see how it behaves, and not just from looking outside it runs is not necessarily enough. So if you really want to know your application, put, for example, Visual VM on it, use a different JVM and see what happens. Now, switching to a different JVM is very easy nowadays. You can use, for example, adopt.openjdk.net and choose the version you want, and yeah, just put it on your class path and go with it. So it's as easy as that. But why should you go to all this trouble? Well, if you can make your app run less costly regarding memory, regarding CPU usage in the cloud, you can save money there. And if you are a customer that says, oh, can we make our application running cheaper? These are the things that you can do. Because in the cloud, CPU and memory are mostly the big part of the lion's share of your bill. There's one catch though. You cannot just use any JVM for your application server in any case. Some application servers, and if you have a support contract, demand or ask, okay, if you have, for example, a Red Hat application server, use the Red Hat JVM. If you don't, we cannot or won't or cannot fully give you support when something goes wrong based on your support contract. So even though your application can run on a different JVM, a support contract can influence which choices you have or have not. And if you are not familiar with this concept, you should maybe ask your architect or other people inside your the company you work to see if there is a support contract and what that entails. So now we can build and run our app. We have discovered the options. Now we really want to deploy it in an environment where it matters, like production, because we want to make money with it or some other goal. And nowadays we kind of are accustomed or not Docker or containerization in a more general sense is the way to really run and ship your applications. And although Jakarta EE and MicroProfile and Spring didn't intend to evolve with the containerization in mind, because containerization is fairly new, it's a perfect fit there. It's a very nice that it turned out that way. So if you look at this screenshot, you see the layers of a certain Docker image from Payara, and you see the Payara application server in a layer 79 megabytes, but the app I've deployed on my Docker image is only 5 kilobytes in size. So this means if I have to remotely push my app all the time to a Docker image that needs to be deployed in the cloud, I only have to transfer 5 kilobytes instead of all these megabytes of application server all the time. So if you use an Uberjar and your package contains both your code and your runtime, you have to put all these megabytes into the remote environment all the time. And if you have a team that does it all day, and if you have 20 teams working with you that do that all day, it can make a real difference in performance and costs regarding transfer of the data to the remote repository. So a thin var here is very neat because you only ship what you change, and Docker provides it perfectly. Then there are some, again, things that might not be on top of mind for most developers, but can be important. Shipping your dependencies along with the infrastructure. Luckily, I see Docker as a big part of the infrastructure. It contains your application server, it contains your app that you put onto it, but the Docker image can also supply your dependencies so that you don't have to put them in your thin var. Like you see here, a Derby client is being downloaded and put into a location on the Docker image where the application server can find it. If I would make a new Docker image of this one instance, I have a new Docker image with the base image from Payara, but this new instance always contains the libraries that I have put on it. So if I can determine that the libraries I have put onto my Docker image are safe, I can reuse that Docker image without having to rebuild and re-download the dependencies all the time. So my infrastructure with Docker is enhanced because the infrastructure is now, again, more complete. And again, I only have to deploy my app on it, which only is a few kilobytes in size, and the infrastructure is more stable and predictable. And predictable and repeatable, these can be requirements of your project from, for example, an enterprise architect or an auditor that says, I want to have a build at a certain time, that I want to see the code that was deployed at a certain time. If you can use the Docker image that was built then and the app that was compiled from a single hash in Git, for example, you can reproduce what was being produced then. If you then, for example, use Spring or other means, you have to build a fat jar and again download the dependency from the internet, you're not necessarily going to end up with the same artifact that you have built before. So it's not predictable anymore. So if this is important for your project or for someone, Docker, Jakarta EE, and thin bars in the most thin bars make even these requirements possible. But to get your app into the cloud with Docker, you have to, of course, to choose which Docker image to use. Now, it at least should contain a version of Java that you choose, a runtime that you choose, and your app, as I have just shown in my previous examples. But when you are developing with Docker, you can use Docker Compose locally. You don't necessarily have to mimic a complete cloud environment on your own laptop or development environment. That's nuts in my sense. If you use Docker Compose, you can spin up an environment that at least acts like it's a cloud environment using Docker, for example, Kubernetes. So you can test functionally if your app does what it does in a environment that looks like a containerized environment with all the environment variables. You can ship that same image that you tested locally anywhere to, for example, production, where it runs in Kubernetes. That exact same image with different environment variables should run there, and it's predictable what came there and how it got there. And in the end, what you deploy there for Kubernetes doesn't matter. And because of the options that we have just discussed, you can deploy different compositions of Jakarta EE and MicroProfile or even Spring that have a whole different purpose, but Kubernetes is fine with it. Because MicroProfile exposes health endpoints, for example, exposes Prometheus metrics, for example, that can be used. And functionally, for your business software underneath, you can use all these Jakarta specifications to really build enterprise software using JSF for the front end, which connects via a MicroProfile REST client with the backend server that uses fault tolerance and all this kinds of cloud native stuff to make sure it doesn't fall over. And there's another server that does the database stuff. And in between, it's all translated with JSON between the servers. So this way, you can still use Jakarta EE and MicroProfile in a very modern way. And with options you have, tune it according to your needs. So summarizing, like I have told, Jakarta EE is a feature-rich program model that only gets richer over the years. Because with Jakarta EE 10, there's a lot of traction from the community, a lot of questions that we have to solve, and features that are being implemented. So we will have a lot of work in the coming years to evolve Jakarta even further. And like I said, building it, running it, portability, scalability, all that kind of stuff, all fits within the Jakarta EE ecosystem. Would you like to know more? You can always look up the Jakarta EE website or GitHub. There's a lot of information to find, also for MicroProfile. And if you are really interested in what is being discussed, subscribe yourself, please, to the mailing lists. And if it's important to you or someone in your company to see what adoption of Jakarta EE nowadays is, please download the developer survey report. And that contains all the details about the adoption of Jakarta EE and MicroProfile compared to Spring and other frameworks that are being used for enterprise Java. So this was my session. I thank you all for listening. If there are any questions now or later, you can always contact me. I'm happy to discuss. And I hope you have learned something today. Thank you.
Thank you very much. So are there any questions from the audience? Okay, please come here so Edwin can see you.
Hello.
Hello.
Thank you for your presentation, and I have a following question. As far as I am not really familiar with Jakarta EE, but I have worked with Java EE some times ago. As far as I understand, Jakarta EE is still a collection of interfaces.
Correct. Yes.
Yeah. Do application servers usually allow us to choose a specific implementation of these interfaces? Like, for example, a specific implementation or even a specific version of GPA implementation, because that is the issue I encountered once, and I was able to solve it with Spring framework. So I'm interested. I'm interested in how I would approach that with Jakarta EE.
Yeah. Okay. Thank you for your question. I can answer that. With the Java EE, there was the concept of a reference implementation. So you had the specification, and there was always one preferred reference implementation. Like for JPA, it was Hibernate. Yeah, there are more. It's not on the top of my head, but there was one implementation for the specification. Now, under the Eclipse Foundation, we expect more implementations for a specific specification. So this concept of reference implementation is going away, but there are still preferred implementations of the specifications. Like Hibernate is still a preferred, I think, implementation for JPA, but Eclipse Link is also available. And some application servers leverage Eclipse Link, and some will supply Hibernate. As a developer looking at the black box, you shouldn't really notice that, unless the application server or vendor provides options that you can use for Eclipse Link specifically or Hibernate specifically in the application server for you to tune your app in that context. So if you start looking at it and working with it, then it matters. Otherwise, your app can adhere to the specification and it shouldn't bother which implementation it uses. Does that answer your question?
Yes, but if for a specific reason, like for example for compatibility with other libraries, I need a specific, for example, a specific version of Hibernate. Does it mean I have to look for a specific version of application service, or am I able to somehow override it?
Yeah, I hope I answered this question right, because I think I know what you mean. Like I said, you don't have to really bother about which version is being used in an application server as a developer, unless you expect a new version of the library being used because there was a bug or a feature has been added or something like that.
Yeah.
So then it matters which implementation you use. But if that doesn't matter for the code you are writing, again, you shouldn't bother. But I have been also in situations where you're waiting for a new version, for example, from Jersey or Eclipse Link, because we wanted to fix something or a new feature. And that was usually supplied with an application server update. So yeah, unfortunately, sometimes you have to wait for that. But sometimes via the support contract, we also could get an earlier update supported that, yeah, patch the application server so that we could continue and later use the fully supported new version of the application server. Okay, does that answer your question?
Yeah.
Okay,
absolutely.
thanks.
Are there any more questions? Okay, I have a question. Well, I'm not really enterprise developer, guys, so this may sound stupid, sorry for that. You stressed several times that you have thin jar, and this is the only thing you have to deploy. But I think even if all the implementation of Jakarta EE and MicroProfile is already provided by your application server, you may still need many other stuff, for example, like Guava libraries, some Apache Commons, whatever, some login library, and so on. And where should I put it into that thin jar or somehow externally?
Yeah, I ideally, like I tried to explain, is you should not put it in your thin jar because it becomes fat. You should put it in a location where your application server can find it, so it is being put on the CAS path by the application server, and where he can find it can be either in a Docker image somewhere or on a file system somewhere.
But this, I guess, complicates the deployment procedure because I need to make sure that my application server contains necessary versions, and what if I want to bump the dependency version? I will need to update the class path, so probably I will need to update Docker file or something like this. No?
Yeah, that's correct. You have to put more work into making this as proper as possible because of some other reasons or requirements that you need to solve. If, for example, completely hypothetically doesn't matter anything, you just put everything in your Filbar, it becomes Fed or Uber even, and just run it. But yeah, there can be requirements that say you need to put it somewhere else because it's more secure or stuff like that, like I explained. It's choices. You can make it work for you in many ways, but yeah, some requirements drive more maintenance in how you do things.
I also don't quite believe, or probably I didn't understand completely the statement about security, like if you have fed var with Spring, okay, you have all the dependencies inside and you may have vulnerabilities there, and if you have thin jar, there is only your code and less code, it should be more secure. But to my understanding, you have also big pile of code inside that application server, and there are also vulnerabilities there. So you just moving the focus to another place, but you can still be vulnerable.
That's true. It doesn't solve the vulnerability problem. Within the application server, it's less likely that you have an unexpected vulnerability by just building your app. And you have the benefit that the vulnerability is in the application server that is under the control of a vendor that should know how to fix it as soon as possible. So you're correct, it's not fixing the problem, it's moving the problem to someone or something that can better manage it. I hope that helps.
Okay, thank you. Thank you for interesting talk again.
You're welcome.
And I'm not sure whether there will be any discussion in discussion zone, but if anybody wants to ask more questions, please join. The link should be in Telegram channel. And thank you, Edwin, and goodbye. See you.
Okay, спасибо.
Спасибо.